Hey, what's going on, guys? This is Mr. Holmes. I'm here to take you through the notes on 3F, which is further expansion. Right, so in this lesson, you should be able to use the distributive law to expand and simplify expressions. Guys, this is kind of the pinnacle of what we're going to be doing. This is the last section, and so it requires a lot of organization. And so for that reason, over here on the side, I have decided that I'm going to color code all of the different types of terms. And so if it's a quadratic term, it'll be green, so forth and so on. All right, so how do I use the distribution or the distributive law to expand and simplify this expression? It's a lot like FOIL. We're going to multiply each of the terms in the first set of parentheses by each of the terms in the second set of parentheses. So 3x times x squared. Well, the 3 is going to stay the same. So 3 will stay the same. But x times x squared will give us x to the third. Think about how many x's there are. There's 1x, 2, and 3. 3x's all together. All right, then we'll multiply 3x times negative 4x. So 3 times negative 4. 3 times negative 4 is negative 12. And x times x is x squared. So very much like that term right here. So x times x is x squared. And then we'll multiply the first term times the last term. So the first term in the first set of parentheses times the last term in the last set of parentheses. And so 3x times 1, 3x times 1 is just going to be 3x. So 3x. Now, the organization piece. We're going to go to the 2. So we're going to go to this 2, and we're going to multiply the 2 times x squared. We're not going to put it over here. That would be bad. What we're going to do is we're going to put it down below. So 2 times x squared is going to be plus 2x squared. So notice where I put it. That's a strategy. All right, I'm going to put it down underneath the negative 12x squared because those are like terms. You're going to see me do that quite frequently in this video. All right, so then we're going to do 2 times 4x, 2 times 4x, and we'll multiply 2 times negative 4x. That's going to give me minus 8. So 2 times negative 4 is negative 8. Negative 8x. And we're going to do the last. So that's going to be 2 times 1. 2 times 1 is 2. So we'll do plus 2. And we're going to draw a line underneath it. Now, pause the video if that doesn't make sense. Pause the video and go back, watch that over again to make sure you understand what we did there. And if you don't, make sure you ask questions tomorrow. All right. So the 3x to the third, we're going to drop down. There are no other cubic terms. I'm using that vocabulary, cubic terms. All right, there are no other cubic terms. But we're going to drop down now the x squareds. There are 2 of those, so negative 12x plus 2 x squared gives me minus 10 x squared. All right. Then we're going to drop down that linear term. So we're done with the cubic. We're done with the quadratic. We're going to drop down that linear term. So positive 3x minus 8x. So 3 minus 8 is negative 5. Let's change that color. Not sure why it didn't change. Let's try one more time. Let's see if that's right. Okay. Negative 5x plus 2. All right. That is going to be our expanded form. And that'll be example 23. All right. Let's go on to example 24. Okay, so here we only have one set of parentheses, right? So we're thinking probably pretty easy. But it's going to take a little bit of expansion, and then we're going to distribute. So first thing we're going to do is we're going to rewrite this as x plus 3. Let's grab the correct colors. So x plus 3 so x plus 3 times x plus 3 x plus 3 quantity squared. Okay, so I've done this for a very specific reason. I need to expand this out. I'd like to avoid having 3 sets of parentheses. I might have 3 sets of parentheses later on in a different example, but for right now, I don't need to have that. We're going to go back to that last video. If you don't remember from 3E, this is a perfect square expansion here. And so we're going to deal with that last set of parentheses first. So we're going to do x plus 3. So x plus 3. And then over here, remember in a perfect square expansion, we're going to square the first term. So this is going to become x squared. We're going to double. So we're going to double. And I'm using that plus 2 because of that right there. So or that plus sign because of that there. So double the product. So that would be x times 3. Then we're going to add, always add on the end there, the 3 squared. So 3 squared. All right, so in that first step, all I did was do the perfect square expansion, and we're going to rewrite it. Here we go. X plus 3. And then on the inside, we'll have x squared. And then we'll have plus, so we get the 2 times 3, which is 6x plus 9. Okay, and so now it's going to look very similar to the last example. So a little less conversation here, a little bit more action. Let's go ahead and just go through this. So we're going to multiply first term times first term times second term, and first term times the last term. And so if we do that, we get, let's see here, x times x squared, which is x cubed, x times 6x, which is 6x squared, and x times 9, which is plus 9x. Okay, so far so good. Don't be afraid to pause the video, go back and rewind it, look at it more than once. So we're going to multiply the last term times the first, last term times the second, last term times the third. I want to move that up just a little bit so that we have room. Okay. All right. So let's start off with 3 times x squared. So this will be plus 3x squared. Okay. And then 3 times 6x, which is plus, so 3 times 6 is 18, 18x. And then we've got 3 times 9, which is 27, so plus 27. Okay. Now, what I did differently on this one was I did not write it underneath, okay? But with the use of those colors, and I'm not sure why I got this one. Let's change that color. Sorry about that, guys. This is, after all, this is an imperfect thing, so I think I hit the wrong deal there. So this was x times 9, which was 9x. Okay, so why I did this in color is so that you can see the like terms pretty quickly. So another way to do these guys is to write them in a straight line, and then notice the coloration, put those terms together. So we're going to put our x to the third by itself. It's the only orange one. Then we will put our x squareds, our quadratics together. So we've got our cubic, it's all by itself. We're going to put our quadratics together. And so our squared terms, so 9 plus 3, or sorry, 6 plus 3 is 9. So we'll have plus 9, so plus 9x squared, plus, so 9 plus 18 is 27. So 27x plus 27. Okay, plus 27. And that'll be example 24. Okay, so we've seen two different ways. Which way do you like better? Do you like the stacked way, where you can see the terms right there by each other? Then I'd recommend doing it the stacked way. I personally love the stacked way, so I'm going to do the last example as the stacked way. Do you like the one that's in a straight line? Some people like that better. For the one that's in a straight line, just be careful. Make sure you get your terms together. And let's go ahead and look at the last example, example 25. All right. So on this first one, let's go ahead and cover up. See here. I think we can remember what we're doing here. So let's go ahead and cover that guy up. Okay. So we're going to do one example at a time. This first one, I'm going to distribute the x into the parentheses first. Okay. And then I'm going to go through the problem. So I'm going to distribute the x into the parentheses first, but it's only going to get distributed into one set of parentheses. So be careful on that. All right, so x times x is x squared, x times 3 is 3x, so plus 3x. All right, so we got that guy taken care of. Then we'll do x plus 2. So x plus 2. X plus 2. And then this is going to be just a simple FOIL expansion. And we've seen this one. So we're going to do first, then outer. So that's going to be our x to the third. So this will be our cubic term. So x to the third. And then, let's see here, x squared times 2. X squared times 2 will be 2x squared. So we'll have plus 2x squared. And then we're going to do, on that next line, we're going to do 3x times x. So 3x times x is plus 3x squared. And that's going to be this first term times the first term. I'm sorry, the second term times the first term. And then we're going to do 3x times 2, which will be, let's see here, 6x plus 6x. Now, a couple different ways that you could have done this problem. This is just one of them. You could have also, let's see here, let me get this written out here, 5x squared plus 6x. So a separate way that you might have done this is you might have FOILed first. Okay, so you may have FOILed these two terms first, or these two sets of parentheses first, in which case you would have gotten x squared plus 5x plus 6, and then you would have just distributed the x in afterwards. So feel free to do it however you want. You get to be a little bit creative here, because you do have all the tools that are necessary to go through these problems at this point. So let's take a look at that last part of example 25. And this is kind of like the apex. This is kind of like the last deal. We're going to do FOIL twice. All right. So for the moment, we're going to forget about this term right here. We're just going to deal with these two parentheses. So we'll multiply here, we'll multiply there. Okay. And we'll have, let's see here, make sure I'm using the right color. So x squared, right? Okay. And then we'll have x squared. We'll have x times -3, so we'll have minus 3x of 2 times x. So that's going to be the inner terms. And then the last terms, and so x times 2 times x would be plus 2x. Okay, and then we'll have 2 times -3, which is -6, minus 6. Okay, and then we'll have x plus 1. Okay, so here we are, and we've got this parenthesis on the wrong side from where we've been at before. You're going to notice it's not a problem. We're going to go with kind of a quick rearrangement, and then we'll solve it. The book actually doesn't do this rearrangement, and I think it's really important, so I'm going to do it. I think it's important for consistency to have things look the same. So x squared, let's simplify this now. We have minus 3x plus 2x, we're going to have a minus x. So minus 3 plus 2 is -1. We had that coefficient 1 when we have it. So then minus 6, minus 6. Okay. All right. So then we're going to do first term times first times second, first times third. Okay, we're going to use our good colors here. So x times x squared is x to the third. Okay. Then x times -x is minus x squared. Then x times -6 is -6x. We're going to go down to the next line, and we're going to do the second term times the first, second term times the second term times the third. Okay, so we're going to start off here with 1 times x squared. So we're going to have plus x squared. That's kind of fun. 1 times -x is -x. And 1 times -6 is -6. Okay, so we put our guys together, we add the 2 rows up, and we have x to the third. This is why I said it was fun, because -x squared plus x squared, these guys are actually opposites, so they cancel out each other. Then -6x minus x is -7x, -7x, and then minus 6. Thanks for sticking with me through this long video. I know it was one of our longer videos, but lots of good stuff in here, and probably lots of good questions too. So if you have questions, please ask me in class tomorrow. Otherwise, we'll catch you on the flip side. So see you tomorrow.